10-5 today in Advanced Algebra 1, and we're finally kind of finishing up how we could like show all of our quantitative data. We've done dot plots, we've done stem and leaf plots. Today we get to do the box plot, and we actually get to do the math behind, are there outliers, are there not outliers? Up to this point we have just said this is possible, looks like this is going to be an outlier, right? We get to figure out mathematically how that is. So here's this formulas right here. We will come back to it often. I would say this is a pretty important practice sheet because it's got some formulas of how to find a low outlier and how to find a high outlier. Let me kind of explain that real quick. Would you believe in this classroom right now, when it comes to ages, my age is too high? Would you agree with that? It's like a high outlier. You could have also put a 2-year-old in here. Wouldn't their age be too low? You know what I mean by a high outlier and a low outlier. 5-number summary. These summary statistics give that to you. The minimum, the first quartile, the median, the third quartile, and the maximum. Those will be used to make a box and whisker plot. And then that's what a box plot is. It just takes those numbers and makes a visual representation of the 5-number summary. So it's just like, hey, what are these 5 numbers? Where's your middle? Where's your other, like, middle of the first half? Where's your middle of the second half? And then your minimum and your maximum. State Assessment had some questions about box and whisker plots also. This textbook calls them box plots. A lot of people call them box and whisker plots. So it's just kind of all in that neighborhood. So let's do this. Let's record the data from our activity. So if you were watching this on the video, this is not your data, but we're at least going to go with it. Like if you were in a different class, it'll just be different, but you can use this data. Here she is, right? What is the 5-number summary? So let me snip this guy out and just put it into our page so I don't have to keep going back and forth. What is our 5-number summary? Here we go. We'll start in order. It should always be done that way. What's our minimum? This is how many states this particular class has traveled to. What is our minimum number of states? 3. Then we'll go with Q1. The first quartile is 8 states. Are we okay with that? Then the median is next. Our median number of states was 11. And then the third quartile is 17. And then the max is 26. With technology, I would say shame on you if you can't get the 5-number summary right. It tells you all 5 numbers in the summary statistics. Yes, you may have misread something, but still, it's there for you. All good? It says, what's the interquartile range, right? So let's do it. We already found it on today's activity anyway. So isn't it 17 minus 8, which would be how much when we calculated that? What is 17 minus 8? That is 9, right? But before we do that, let's I take that back. We'll calculate if there are outliers first. So if we're going to make a box and whisker plot, which we're going to do by hand here to the right in a moment, we should first realize, is all this data good or bad, right? What I mean by that is, are some of these outliers? So since we kind of have this, let's just take a guess. We see a dot plot, right? What is our guess? Do we have any possible outliers? Shout them out. 26 could be possible. Don't know yet, right? We'll find out when we do the math, right? But 26, maybe 3. Are you with me on that? You know, it's definitely down in the ends, right? Either too high or too low kind of makes sense. By the way, this particular data we decided was bimodal, if you look at it, you know, kind of bimodal. So let's do the math behind it. So how we do that is, first things first, let's start with low. I would like you to make like a little category, because you'd have 2 possible outliers, right? You could have one that's low, you could have one that's high, and yes, you could have both, right? You know, you could have one that's too low and too high. So here's how you find the low outlier. We do Q1, which is 8. Sorry, use your pen. 8 minus 1.5 times the interquartile range, which in our case is in our interquartile range 9. Right? So grab a calculator and let's just punch that in. 8 minus 1.5 times 9. And what we get does not have to be a number of our data set. I got negative 5.5. Did you get that also? So this number right here, homework's going to call it the low fence. You know, I've never heard that before until I started looking through the homework that I assigned. But this is like the low boundary is what I usually call it for if you have been to negative 5.5 states, you still are not considered a low outlier. If there was any data below negative 5.5, that's why it says less than right here. Is there any data below that? Well, obviously, can you believe that makes no sense to go to negative 6 states? Are you with me on that? So what do you think? Do we have any low outliers in our data? So there are none, right? There are none. Because the lowest value we have is 3. The lowest possible value, in my opinion, should be 1, unless you are not in the United States when you're taking the survey. I guess that could be 0, right? You know, but since we're all in the United States, it's like the lowest possible value is 1, so there were no low outliers. Well, let's see if we have any high outliers. How you test the high one is instead of using Q1, guess what you use? You use Q3, the third quartile, which is 17. And what also changed? It's not a minus, it's a plus, right? Because we're going to see if we're going too high, 1.5 times the interquartile range. So we were checking to see if 26 was. Let's punch this bad boy in. 17 plus 1.5 times 9. And that is 30.5 is what I got back. This is called the high fence, or the high boundary, 30.5. Like if anybody in this room had been to 31 states or 32 states or 40 states or anything like that, anything over 30.5 with our data, that would be a high outlier. So my question is, do we have a high outlier in this case? The highest was 26. Is it an outlier? Nope, so we have none. Are we cool with that? Well, what I want to do is now make a box and whisker plot of this. So we're going to use the 5-number summary to kind of make that box and whisker plot. And we've got to go from low to high for sure, and we've got to have a decent scale. We've got to get from 3 to 26. Here's my first question. Could I make it counting by 1? So if this was 3, that would go 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Holy luckiness, Batman. Can we make it counting by 1s? Yes. What if you couldn't? What would you have to do then? You count by 2s, and I would not start on 3. You know what I'm saying? It's like you'd start with 2, you know, and then 3 would be in between 2 and 4. Does that make sense? But we can make it counting by 1, so let's do it. But watch this. I'm going to go 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Did I still count by 1s even though I only listed every other one? Because it is painful to have to sit there and write every single tick mark on there, but every one of them is still value of 1. Like this one right here isn't at 11. Are you with me on that? But I just listed every other one. Are you with me on that? So, cool. Here's what I want to do. We're going to make a box and whisker plot. Just out of curiosity, have you ever seen one before, like a box plot? Kind of know what they're supposed to look like. So here's what we'll do. We're going to put the 5-number summary as just dots real quick. So who is our minimum? 3. Let's put a dot right here and put a 3 above it. Then let's go put our maximum next. Who is our maximum? 26. And would you do me a favor? This is sort of a different way to make a box and whisker plot. Take the straight edge that I have provided you. Hopefully those two are at the same height. I should have said that. And connect them together. So notice I didn't put mine at the same height. I'll bring my 26 dot down a little bit. So I'm going to erase. And I put that dot too high. But I want to make a graph pretty. So there's my 26. Cool. Then let's go put our first quartile of 8 on here. Bada boom. And our median is 11. And our third quartile is 17. And then what we'll do is we'll make a box around the inner quartile range, right? So take your straight edge, and let's pick a measurement here. Do you see the centimeter side of yours right there? Let's make our box, let's go with 1 centimeter high, right? So try to split it like this. if that was 1 centimeter, would you believe that this is like a half a centimeter, like 0.5, and this is like a half a centimeter? So try to make your box like 1 centimeter high. It doesn't have to be perfect, but then we'll do it again over here. Use a straight edge, buddy. And then we will do it again on the median. So you make 3 little up and down guys. I missed a little bit. All of them 1 centimeter high. It doesn't have to be perfect. I just want it to be kind of pretty, right? So if you're off a little bit, no big deal. And then connect those together to make this box. And then what's really truthful is the line in the middle should probably be erased. So like this part, erasing that, and erasing that. But I don't think I'll ever have you make a box and whisker plot again by hand because the applets can do it. I just felt since it's like our first rodeo with this, I would like to make the box and whisker plot. Yes? So there is the box and whisker plot. Things I would like to talk about it. How much of the data do you feel is in that green area compared to this pink area, compared to this orange area, compared to this blue area, percentage-wise? Remember, those are quartiles, right? So if you're not sure, no big deal. Guess with a neighbor, how much of the data is in each quartile percentage-wise? What do you think? The answer is 25%. Where did you get 25% from when I say quartile? Divide by 4, right? Now, does it look like it's evenly split? Which one looks the longest? The blue one. You know why? It's because the data gets spread out in that one. But 25% of the data is in the, like, past the third quartile. 25% of the data is in the first quartile. It's like it's split into 4 equal parts, but it doesn't mean that the data is spread evenly. So another quick question if I go back. I'm going to highlight something in here. What percent of the data is in the box? It's all split into quartiles, right? So what percent of the data is in the box? 50%. That's why last time the interquartile range is like the middle 50% of the data is doing this. So it's split up pretty darn close to that. So back to this. Would you believe that I could have turned this into a box and whisker plot real easy with the drop-down menu, and it would have made the box plot for me, right? So it can be done, and it's just the same old story in that one. So let's keep on rolling. It says Ryan and Brent were curious about the amount of French fries they would get. Did I? Yeah, is this the next question, or did I skip over one? Okay, thank you. So these 2 guys right here went to Burger King. Please do not hold Hayes' Burger King into like your thought of bias. Hayes does not have the best Burger King in the world. I can tell you there are some Burger Kings that are better than Hayes' Burger King. But still, they said, yo, man, like how many French fries do you get when you get a large fry? They didn't count up the number of French fries, but they just measured the weight of them. So they went to all these different Burger Kings and got a large fry, and this is the data. Could you please go to the computer, because I want to practice us doing some of these moves, and copy the Burger King data, and let's find the 5-number summary. So we are finished with this data right here, if you wanted to close that out, or you could just start a new applet. But we will go to the data needed on here and copy the Burger King fries and paste it into one quantitative variable single group. And then I will let you get the summary statistics there for the 5-number summary. So here is the summary statistics from that. The applets always make it dot plots. So 5-number summary, 152 is the min, 163 is Q1, 166.5 is the median. I just rounded it to 1 decimal place. I know it's got 3 decimal places. And then 170 and 173. Are we okay with that? Let's find the interquartile range after that. It is helpful if you show me what you're subtracting, right? Instead of just putting a number, you know, like show me that you're doing 170 minus 163. Right? Which is how much? 7. Let's determine if there are any outliers. Well, first, let's just look to the dot plot and guess. Do you feel that we have any outliers? Which one looks like an outlier? 152, but we don't know that for sure, right? But he is very possible. So they'll have lots of questions on homework like this. It's like, what are the fences? What are the boundaries for this? Let's use that formula. So we'll do the low outlier. I like to do that first. And remember that formula is right there. You got to use Q1, which is 163 minus 1.5 times the interquartile range of 7. So we'll punch that in. And if any number that we have in our data set is below this value, that will be a low outlier. What is the value of our fence right here? 152.5. So let's talk. Do we have any pieces of data lower than 152.5? Barely, right? You know, barely. But 152, I'm going to kind of go right there and circle it, isn't low outlier. So we will say yes, 152. But there could be some high outliers. I really doubt it based on looking at this data, but they're going to ask you to find the high fence anyway, right? So we will do it. So high. 173 plus 1.5. Plus 7 times 1.5, I should say. So we'll punch that in. Plus 1.5 times 7. I kind of rearranged that. It's the same thing, 1.5 times 7, 7 times 1.5. So did you get 183.5 for the high fence? Do we have any pieces of data bigger than 183.5? Here's the serious question. The whole point of this entire first 5 lessons is it easy to tell by looking at this? If I said, hey, are there any numbers bigger than 183.5? Looking in that green box, isn't it challenging to find that? Looking at this, isn't it pretty darn easy to see if you have a number bigger? Like making the graph is easier to read the data, right? So the low outlier was our big one, right? So now let's go and make ourselves a box plot on the applet. And the cool thing is, so we got the applet over here. The cool thing is the outliers show up differently. If there are any outliers, that's why earlier when we made one by hand, we should have calculated outliers first. They don't become a part of the box and whisker plot. But I do want to make sure you know they're still a part of the data. We did not like eliminate it from the data. It's just showing someone that's reading it. It's like, hey, here's like the data, and this guy right here, he is not fitting, right? You know, he is an outlier in that case. So the cool thing is, even though this will tell you if there are outliers or not, when they ask you for the fence, this doesn't tell you what the fence is. You have to go and do the math by doing the plus or the minus, the interquartile range times 1.5, right? So you'll still have to do that. What percent of the data, is the question here, were less than 170 grams? Man, we're going to be in like awesome shape, because is 170 part of the 5-number summary? What do you think? Like the 5-number summary is what the box and whisker plot is designed around. So what percent of the data are less than that? What do you think? 75%, because isn't each one of those in a quartile, right? So 75%. And it's not perfect. It probably would say about 75%, because you could be off a little bit here and there if you had to like split the two terms to find the third quartile, because it was between two values and stuff. So it might not be perfect, but it's very close to it. All right. Be careful, though. Even though box and whisker plots are kind of neat looking, they don't show you a lot of data. Would you believe right here, this is data from, like, you know what Old Faithful is? Like in, I can't even remember which national park it is, Yellowstone National Park, is that right? You know, it's like a geyser that shoots up water. So, like, they recorded 220 eruptions of this, and they said, how long did it last? So, like, here's the dot plot. How would you describe that? Say bimodal. How would you describe that? Yeah, it either, like, erupts for basically 2 minutes, or it erupts for like a little over 4 minutes. Are you with me on that? Isn't that kind of like what the data in the dot plot is showing? Ain't no way you could see that in a box and whisker plot. The visual representation of a box and whisker plot hides a lot of juicy information about it. So I still think out of all the ways we could look at data, the dot plot still shows us almost everything we really want to see about that guy the best, right? So watch out for that. And then let's compare. If you're a sports guy, Like, they've been asking this for a long, long time. Who's the GOAT in basketball? Is it Michael Jordan or is it LeBron James? It's a shame that a bunch of people get thrown out because I still feel that Larry Bird is better than most of those guys if you actually watched and paid attention to like how basketball was. But it comes down to those two all the time. So here's what we're going to do. We are going to do a side-by-side dot plot in this one. So let's first graph this data as dot plots. What we have here is just the average number of points they scored for every season they played through 2019. So it's not that up to date because LeBron is still playing, believe it or not, and it's been 6 more seasons since we've had this data. So it's still old data compared to 2019. So let's do this. It tells you what to do here in the instructions, but let's go to the applets. And I'm going to just go back to the menu right here. Get to the menu. We want to do one quantitative variable, but we're going to do multiple groups because we're going to compare LeBron James compared to Michael Jordan. So who's on top in the chart? Is it James or Jordan? So let's put James right here and Jordan right here. And then go back to our spreadsheet. You have to copy the data separately. So if you want to do all of LeBron's stuff right here, copy that, put it into our applet under the James category, and then we'll do the same thing for Michael Jordan. And then we'll do this. And begin the analysis. And it should make 2 dot plots on top of each other. You could probably end up doing more if you wanted to like compare 3 things. You would just click the add group. But we'll look at the 2 different bits of data right there. I just wanted you to practice how to put that in because there might be some homework questions that have you compare 2 things. But let's take a look at them. All right? By looking at this data, we should probably do a little bit of like describing the data to see if we can inform ourselves who is actually a better basketball player according to these statistics. So first, let's look at the shape, right? They say describe the shape, so let's do this first. Let's do James. And let's describe the shape of this graph. I will do this. Talk to me. First, talk to your neighbor. Fairly symmetric, skewed right, skewed left, bimodal, or fairly uniform. What's your feelings? I hope it came down to 2 of them, right? What are the 2 main choices there? Skewed left or fairly symmetric. I feel pretty good with that. I put both, right? You know, I really do say if I had to pick, I would pick fairly symmetric. If you chose skewed left, I don't have an argument for you. You know what I mean? It's like I can't say you're wrong. So I'm just going to call it like fairly symmetric. But if you put skewed left, I understand what you're looking at. You know, I see that. How about Jordan? Let's draw the cool little thing on top of his. He does have a peak, right? So what do you think about Michael Jordan's data right there? Yeah. Skewed left, very possible for fairly uniform also, you know, but because there is a peak, I think we'll go with skewed left. So just right now, is that enough to say who's better? No, we're just looking at the shape, right? Would you be able to say who's more consistent? Who's more consistent? LeBron. That means he should have what kind of standard deviation? Smaller or bigger if he's more consistent? Smaller, because he deviates less from his average, right? So, which he does, right? His standard deviation is about 2.3. Jordan's about 4.7. Cool. So let's see what else they say. Let's change them to box plots, right? So let's go do that on the applet. Let's change it to a box plot. Before you do it, do you feel there's any outliers? Sorry, you may have already done it. Do you feel there's any outliers? Looks like this one might be an outlier, right? You know, maybe these. It'll show you straight up if there's some outliers, right? There is definitely some outliers. Whoa, how come LeBron James's like box and whisker plot is so much skinnier than Michael Jordan's? because the data is more consistent, right? You know, it's like 50% of the data is in that little skinny, you know, like interquartile range thing and stuff, you know. LeBron had some outliers, yes. Michael Jordan did not have any outliers in that case, which is kind of interesting. But let's go back and do this. They say describe the shape. We don't need to write it down again, right? You know, we did that on the last problem. Any outliers? You bet there was, right? Oh, they asked for the 5-number summary. Bro, I'm not going to make you write that down right here. Do you understand how to find the 5-number summary? Does that make sense? Right? So we don't need to write it down. But outliers, James had 2 of them. And the easy way to do that, to figure out those values without having to go back through the entire chart, is, would you believe, that is the minimum and the maximum, right? It's in the 5-number summary, right? You know, so they're still a part of the data. They just don't get to be a part of the box and whisker plot. So James had outliers at 20.9 and 31.4. That was his minimum and maximum. And then Jordan had none. The center is the next question they ask us to find. What are you looking for in the 5-number summary to find the center? The median, right? So you're just going to list both medians. James's center is 27.15, and Jordan's is 30.1. And now let's talk about variability. Variability is still the weird one. Our brain doesn't like equate that to an easy number, right? Like mean is so easy. This is average, right? We're getting used to standard deviation. Variability is a measure of spread. But I would like to ask you this. Which one should we use? The range or the interquartile range? Discuss. The range or the interquartile range? Here's what you should ask. Are there outliers? Are there outliers? So what do you think? Range or interquartile range? Which one's going to not worry about outliers? The range, which is the max minus the min, or the interquartile range, which is Q3 minus Q1? I think we should do the interquartile range because don't we have some like skewed data on LeBron James's stuff, right? Because there are outliers in that. So let's do this. Let's go James, IQR, find his interquartile range. 27.95 minus, what is the other number? 24. 26.55, right? $1.4. Is that right? Cool. Then find Michael Jordan's. Michael Jordan's. We used the interquartile range instead of the range because we had outliers, right? And if there are outliers or very skewed data, we want to use the interquartile range. And who varied more? Michael Jordan varied a lot more, right? A lot more. Easy to tell in a box and whisker plot because Michael Jordan's, like, the box of the box and whisker plot is way bigger than LeBron James. I shouldn't have used blue right there, but it's way bigger. Like, it's easy to see the interquartile range on a box and whisker plot visually because that's what the graph is all about. So who was better? Still a matter of opinion. If we go back to the actual data, you know, like bringing up my point earlier, where is the actual data? Right here. These first few seasons, these low ones, I don't know if these are in order or not. There was a couple of other guys playing in the league back then called Larry Bird and Magic Johnson, right? That really kind of like put some lower numbers on Michael Jordan. And then by the 90s, when those guys were out of basketball, then Michael Jordan kind of took over. He also got better, you know what I mean? But it's just like, hey, when LeBron came in, there wasn't too many people that could challenge him. Kobe, you know, could do it. You know, maybe a little bit of Kevin Garnett, but still, LeBron has been very much more consistent. But Them old boys from the 80s had some things to say to Jordan when he started as a young guy. So Jordan got better with age, is for darn sure, right? He got better with age. So anyway, last thing. So where did we end up right here? One last thing right here. The following box plots are those 20 travel times to New York and then 15 different ones to North Carolina. Cool? Let's compare these. It's kind of tough to tell because we don't have the dot plot, but let's describe the shape. What do you think about the shape of like this one? Is it fairly symmetric, skewed right, skewed left, or anything like that? What do you think? Discuss. It's hard to tell. Here's the middle, right? That's the middle for sure. You know, that's the middle. So what do you think? Is it fairly symmetric? Wouldn't the box and whisker plot look pretty even on each side if it's fairly symmetric? So where's it skewed? Skewed to the right. Where's this one? Skewed to the, don't forget, what do you think that thing is right there? It's not a dot. They put an asterisk and said, what that thing? So do you feel that, like, you have to kind of visualize it going all the way out to that? So it's also skewed to the right. Which one's skewed more? New York or North Carolina? New York. You don't need to write all this down. If we just do this out loud, they're both skewed right, but New York is stronger. Is that okay? Any outliers? Very obvious. New York has an outlier at 85. North Carolina has none. They have the data on the back side of this. Like, you don't get the data on the worksheet, but if you remember that was 85. What about the center? Where's this guy centered at? Just kind of tell me roughly where's the center at. Almost 20, you know. Where's this one centered at? Take a wild guess. This is 20, this is 40. Where do you feel that would be? 20... Not 25, that would kind of be like right there, because here's 30, right, you know, halfway in between. So less than 25, more than 20 at a decent guess. It's actually at 22. And then how about the variability? Which one varies more? Here's the real question. What should you look at for variability? Range or interquartile range? Why do you have to choose IQR? Because there are outliers. So now visually, which one varies more? You're only looking at interquartile range, so pink thing versus blue thing. Which one has a more variance in their interquartile range? The New York. Cool. Not much, right? You know, it's not that much longer, but it varies a little bit more. So nice. All right, let's do some homework.